Before we start this question, we need to understand what is asked. So here, what is given to us is that A, B, C, D is a general quadrilateral and P, Q, R, S are the midpoints of the respective sides. Show that PQRS is a parallelogram. So first task is to get that PQRS forms a parallelogram, and then next part is such that area of this parallelogram PQRS parallelogram's area is equal to half of this quadrilateral. So first part in this video we will prove that PQRS is a parallelogram. Now this part is important from the point of view of midpoint theorem as well. We have to take two triangles ABC. So first we take triangle ABC, and in this triangle we say that Q is the midpoint of BC and P is the midpoint of AB. Then PQ is parallel to AC and PQ is also half of AC. Correct. So PQ and AC are parallel and PQ is half. So first part which we mentioned here is that PQ is parallel to AC and PQ is half of AC. Next part we consider triangle ACD. In this triangle also R is the midpoint and S is the midpoint. R and S are parallel to AC and R and S are half of AC. So once we get these two facts, we can combine the statement number 1 and 2 saying that PQ is parallel to SR. PQ is parallel to SR since both are parallel to the line AC. And then finally we can also say PQ is equal to SR since both are half of AC. Condition about quadrilaterals: if one pair of opposite sides are parallel as well as equal, then the quadrilateral PQRS is a parallelogram. So you can mention that PQ is a parallelogram as one pair of opposite sides are both parallel and equal. Now we need to prove area is half of quadrilateral ABCD. That we will see how we can do. Now that we have already proved that PQRS is a parallelogram, it's our first step to start proving it half of the area of the quadrilateral ABCD. So first step, we need to take triangle ABC. So just don't worry about ACD, this ACD, just consider this part. So here we have three triangles. Triangle 1 is triangle ABC. This is the first triangle ABC. So we consider triangles. First is triangle ABC. Next triangle, triangle number 2, which we need to consider, is triangle BCP. So second triangle to consider is triangle BCP. And the third triangle to consider is triangle BPQ. Triangle BPQ. So what we can say that first part, triangle BPC, first triangle BPC is equal to half of triangle ABC. Now why is BPC half of ABC? Now you should be in geometry be prepared to deal with inverted triangles also. So here we have an inverted triangle where C is the vertex. Generally we are habitual to see the vertex at the top. No, this time C is the vertex and CP is the median as B is the midpoint of AB. So BPC is half the area of triangle ABC. Now look at the other triangle, this triangle BCP. PQ is the median. Now PQ is the median, so first part, second part we say PQ is the median, then triangle PBQ or triangle BPQ is half the area of triangle BPC. So this triangle BPQ is half the area of BPC. Now what happens? BPQ is half the area of BPC. Now what is BPC? Observe. BPC, instead of BPC, we can also write that this BPC is further half of, we already know, BPC is half of triangle ABC. Now if BPC is half of triangle ABC, then what we have? We have BPQ is half of half. So BPQ is 1/4 of triangle ABC. So BPQ is 1/4 of triangle ABC. Right? Got it? So the first part is that we prove this part of the triangle BPQ is 1/4 of ABC.
Let's see. So here, now you can see in this triangle, the main part is that ACB is one part of the quadrilateral, and we look at the green triangle. Now, how we see the green triangle? What we are going to do, we are going to rotate the figure slightly. Alright, now C is at the top, and now you can see the green colored part is half of the triangle ACB, because median divides a triangle into two halves which are equal in area. Now we are going to further rotate the same figure. See, now in this rotation, what we are able to observe that this part, the red triangle PBQ, is further half because of the same reason that median divides the triangle into two halves which are equal in area. So PBQ is further half of the triangle PBC. Now how these triangles are related? Let's have a quick look. Triangle ABC is the purple triangle, and this purple triangle is divided by the median CP, which makes the green part CPB half of that triangle in area. So now we see the red triangle PQB. Now what is PQB? It is further half. Now PQB is 1/4 of the area of the triangle ABC.
Now in the next stage, we don't have to consider triangle ABC. Now you can leave out everything above the line AC on that side. Won't consider. You can leave this whole thing out. Now we will only consider ACD. In triangle ACD, first we start SRD. SRD is half of which triangle? But really this time we are starting from the inner triangle. SRD, because SR is the median, SRD is half of triangle SCD. Exactly. SCD. Correct. Now triangle SCD, further SCD is half of triangle ACD, right? ACD. It is correct, half of triangle ACD. Now triangle SRD is half of SCD, and SCD is half of ACD. So SRD will become how much? 1/4, because this is SCD is half of ACD, and SCD, if I take this over here, it's half of ACD. So ACD's triangle ACD, 1/4 of triangle ACD is triangle SRD. So the next point is that triangle SRD is equal to 1/4 of triangle ACD. Now what we need to do is just add these two statements. Now if I add these two statements, I get triangle PBQ plus triangle SRD. Triangle PBQ plus triangle SRD is equal to 1/4 of, if I take 1/4 common, triangle ABC plus triangle ACD. So PBQ and SRD, point to be noted, triangle number 1 and triangle number 2 are together 1/4 of ABC plus ACD. Now what is ABC plus ACD? Right? What is ABC plus ACD? That makes it the whole quadrilateral ABCD. So this triangle number 1 and triangle number 2 are together equal to 1/4 of the entire quadrilateral. Now that we have proved that triangle number 1, that is PBQ, and triangle number 2, that is SRD, is 1/4 of this quadrilateral, we'll take up triangle number 3. Triangle number 3 here, this side, and we'll use one of the most important words in geometry, similarly. You know what happens? Similarly. That's interesting. Similarly, we will say triangle APS, because as it is, the proof is lengthy. We don't expect you to prove the whole thing by taking DD and then you know how. It's not required. You just say similarly triangle APS plus triangle QCR, which happens to be my triangle number 4, they together, 3 and 4, now you must have figured it out, this together will also be 1/4 of the quadrilateral ABCD. Now if I add 1/4 and 1/4, what do I get? I get half. 1/4 plus 1/4, it's half of the quadrilateral ABCD is equal to the sum of these 4 triangles. The sum of 4 triangles. Now the question is, what is the parallelogram PQRS? Parallelogram PQRS. Parallelogram PQRS is quadrilateral, it's equal to quadrilateral ABCD minus sum of 4 triangles. So PQRS is the quadrilateral ABCD minus the sum of these 4 triangles. If you subtract these 4 triangles, you will get the quadrilateral. Now, what is this? This is one thing which we are clear of. What is sum of 4 triangles? That's half of quadrilateral ABCD. So here we get that parallelogram PQRS is equal to quadrilateral ABCD. The quadrilateral ABCD minus half of quadrilateral ABCD. So what is quadrilateral ABCD minus half of quadrilateral ABCD? This will simply be that parallelogram PQRS is equal to half of quadrilateral ABCD. Okay, so finally we have proved that this quadrilateral is half of this parallelogram PQRS is half of quadrilateral ABCD. Okay.
Alright, now let's try to summarize the entire proof in a visual way. We would like to see it with figures. So the first triangle which we have highlighted here is the green triangle BPQ. Now what it is? It is 1/4 of this yellow triangle ABC. Now see, this yellow triangle is not necessarily half in area of the entire quadrilateral, but this yellow triangle and the triangle ACD makes it the whole quadrilateral. Now see, similarly the blue triangle RSD, it is also 1/4 in area of the red triangle ACD. So these two triangles together, they are definitely 1/4 of the entire quadrilateral. Right? Now, what about these two triangles? Now the red triangle APS and the yellow triangle QCR are also similarly 1/4, right? Because now we have to take BD as the diagonal, and then the same way like we proved, we can get that APS and QCR are also 1/4 of the individual triangles. So these two are also 1/4. Alright, now let's see. When I combine this, the blue and the green triangle, they make 1/4, and the yellow and the red triangle, they also make 1/4. So what? Together, what is 1/4 plus 1/4? Half, exactly. So what happens is that these triangles, they make half of the entire quadrilateral. So what about the remaining part? The remaining part will also be half of the area of the quadrilateral. So that's how we get this proof.